What's going on, data devotees? It's Jameson here. This video is about package dplyr. What is it? What does it do? What makes it awesome? And so specifically package dplyr, just as a little bit more context, is part of this broader self-interfacing ecosystem known as the tidyverse. And these are all of these different packages that work together, and the tidyverse is very much associated with RStudio and maintained by many of the staff at RStudio, as well as originally authored by lead data scientist at RStudio, Hadley Wickham, as well as many of his collaborators and other industry leaders. And so it's an extraordinarily common package when it comes to data manipulation, and it's solely designed for manipulating your data in certain ways. Being able to choose rows, being able to filter columns, being able to do advanced grouping or aggregation operations to be able to find out more information about a specific group of variables. And so we're going to look into a little bit more, first starting with an example of what a dplyr expression might look like, as well as going over these key 5 verbs. Now, why are they called verbs? Well, the functions in dplyr are known as verbs because it's built on a theoretical framework surrounding a grammar of data manipulation. And that grammar very much resembles domain-specific languages like SQL or structured query language, and you see that a lot of the functions in the dplyr package are actually the same sorts of functions that you can use in SQL. So if you already know SQL, this could be familiar territory. And if you don't know SQL, you're going to be learning it at the same time as you're learning dplyr to some reasonable extent. So lastly, we're also going to talk about the syntax that dplyr introduces. And this is somewhat different from the syntax that you're accustomed to when it comes to working with base R or core R. And we're going to do all that and more right now. So without further ado, let's jump right in. So I've got RStudio opened up with a relatively clean slate. I've already got my working directory set, and I'm going to press Control-Shift and N to start a new tab. And so let's go ahead and save this just so that doesn't give us trouble later. We'll call this dplyr.r. Again, because it's an R script, we're using the .r extension. And of course, with every package that you use, when you start a new session in R, you of course want to load the packages that you're going to be using. And so in this case, we will use function library to load package dplyr. Now let's take a look at an example of something that you might see in dplyr. So we've now seen empty cars a bunch of different times. We know that it has these row names that represent all the different vehicles. We know that it has 11 different variables regarding each of those vehicles. And if we recall correctly, it is from a 1974 issue of Motor Trends magazine, which is a magazine based in the United States. And so let's make this example statement. Now you're already seeing new stuff just off that first line. This is a key verb that you'll often see. And in fact, one of the first verbs that we're going to start with, we're going to choose MPG and cylinder, and let's choose weight as well. And lastly, we're also going to choose certain rows by using function filter. And if we do that, let's filter cylinders by exactly equal to 8. So there's a complete chain, if you will, or multiple functions that create a single expression that could be executed in a fell swoop all at the same time. And this is something that's typical that you would see in dplyr. So let's see what happens. Okay, so we run that expression. It gets evaluated in the console, and the output is the retention of these multiple vehicles that have essentially passed this filter test of being only 8-cylinder vehicles. And we also have these 2 other variables that we chose with select. We've got miles per gallon, and we've got weight. And so why does this work? I'm going to keep this open here just for the time being. But first of all, there's something happening here with this operator that looks fairly intimidating if you're not accustomed to it. This is called the pipe operator. And if you want to be able to use the pipe operator, a shortcut for it is to press Control, Shift, and M, and that will automatically create a pipe. And so what does the pipe operator do? The pipe operator takes a data frame, in other words, a set of tabular data with mixed values. In this case, these are all the same, but it's still considered a data frame, especially because we have row names. Excuse me. But semantics and definitions aside, this is by all accounts a data frame. And fun fact, the D in dplyr, again, is for data frame. So this is specifically for data manipulation of data frames. And so we take that original data frame, which is empty cars. We've got all 32 vehicles. We've got all 11 variables. And what the pipe operator does is that passes the data frame into a new function. So normally, if I wanted to do select, I would have to name the data frame first. And that's under data, right? That's the very first argument that you would do. So we do data equals empty cars, and then we have the names of the variables that we want to reduce that set to. And so there we've done exactly that. But instead, by passing empty cars into this new function using the pipe operator, we don't actually have to name the data set again. In fact, we can just name the other arguments that we want inside this next function. So essentially, in essence, pipe operators will take what's on the left-hand side of the operator and pass it to anything that exists on the right-hand side of the operator. It could be a new function, typically, and so this is how you can chain multiple functions together. This data frame is moving into the select function, and once that happens, it becomes only 3 different variables. And then this data frame, which is comprised of, again, the 32 vehicles and the 3 variables, gets passed into the filter function. And when that happens, it becomes filtered. So again, with filter, we see that we don't have to call the data argument because we're starting this chain with the actual data set itself. The data are passed to select. It's operated on. Those data now operated on are passed to filter, and we only have to name the data set that we're filtering or we're selecting or any other of these dplyr verbs. We only have to name that at the very beginning. So what's another thing that we're saying? So that, again, that's the pipe operator. Another thing is that, and this is not necessarily unique to empty cars, but we have this kind of bare variable name syntax. So notice that typically in the past or in core R packages, we've done empty cars, $, cylinder. And we might do that for function mean, and that will give us the mean value of all of the values that exist in cylinder. Now that's not very useful when it comes to cylinders, but if we did something like MPG, then that would make much more sense, right? Average MPG of all 32 vehicles is 20 miles per gallon, approximately. And so in dplyr, again, after you've named the data set, you only have to name the bare variable names. It doesn't have to be preceded by this extraction operator and the name of the data set. If you do this, you're going to get an unwanted outcome. It's going to be expecting you to pull not only from essentially the manipulated data already, but then it introduces this brand spanking new version of the data set that hasn't been manipulated yet. And so we don't want that. So that's the big takeaway here, again, is the pipe operators and then also bare variable names. Am I spelling bare right? Maybe it's bare variable names? Who knows? Anyways, I feel like that's correct. So that is essentially dplyr syntax, and those are the two major changes when it comes to using syntax with the dplyr package. But now let's talk about the key verbs. And there are 5 key verbs that we're going to use. We already took a look at 2 of them, but let's go ahead and look at the first one being select. So select really is ultimately reducing the amount of columns you have to just those that you name, or reducing the amount of columns you have to all except for a particular column. And so let's see what that looks like. And again, we're going to use this new syntax that we've learned where we use the pipe operator. And so we pass empty cars, which comprised again, and I apologize for the repetition, but it helps with, I think, retention of this new information. Empty cars has these 11 variables. And so if we use select, which is specifically for choosing different variables, we can say, well, I only want the variable miles per gallon. And so if we run that, it's returned with miles per gallon. Or we can say, I only want miles per gallon and cylinder. And of course, we get miles per gallon and cylinder, or miles per gallon, cylinder, and weight. And so you can see that this is an extremely clean way to be able to reduce the amount of variables you have in your data set. And it's also extremely easy for you to understand as a coder yourself when it comes to deciphering your own code, but also for collaborators to be able to understand. And even people who've never used R before in their life can typically look at a data set like this, so long as they have some data literacy, and they're able to sort of decipher and decode what's going on. And that's another advantage of dplyr, is just the verbosity of it. The fact that with verbose code, you're able to sort of explain much more easily what's really happening in your processing or your data analytic tasks. So cool. So that's select. Quite simple, but we can go even further than that. So I wonder if the period is going to work. Period means all typically, and then of course we're not selecting anything if we leave it empty. So let's go ahead and look at empty cars again. Now let's say that I want to get miles per gallon all the way through weight, and I want everything in between, but I don't want to type out each variable individually. What do? So if I take miles per gallon, I can use this colon operator in the same way that sequences are made. Remember that 1 through 10 will result in the sequence of 1 through 10. It's a regular sequence of integers. So I can use that and say I want miles per gallon all the way through variable weight and every single column that exists in between as they're laid out. And so that's quite nice. It's a nice little shortcut. It keeps your code clean. Now let's say you want all of that, but you don't want displacement or the size of the engine. So you can still use that sequence, but now we can do minus displace. And it gives us that sequence of variables excluding displace. And it's because we took variable disp, and we included a minus sign in front of it, which is telling R through dplyr, hey, don't include this variable. And so that's also the same with, for example, when we look at all these variables again, we can see that let's say we want all 11 variables with the exception of QSAC. Because, well, let's do drat because, that's the one I always forget what it means. So, so what if we want all of the columns except for drat? Well, in that case, we can simply put minus drat in select, and there we have it. So now there's only 10 different variables, and we can pipe this into an exploratory data function like dimensions, and we can confirm, in fact, yes, there are only 10 variables now with the not so conspicuous absence of variable drat, because we said don't do it. Okay, so that is select. Now let's take a look at filter. Mutate's one, but let's talk about basics first. So whereas select is for columns, filter is for rows. And so what does filter do? Well, in effect, you take your data set And let's say we only want miles per gallon that are less than 20. So we're going to look for some, pardon the term, some gas guzzlers. So we'll do less than 20. And you can see that in filter, we're using these relational operators. So we're only looking for things that are true or false. So if you have something else that will return true or false, so for example, is.na, and if we had true, false, true, true, na, so that's going to return as false. Is.na detects missing values, and so we do have one missing value among these 5. So not missing, not missing, not missing, not missing, and missing. And so that's the same thing where filter, if it returns a true, and if we only wanted to filter everything, filter out all the missing values, we could use something like is.na. So this is really anything that will return trues or falses will work with filter. Now, normally you might say, and let's just go ahead and run this. So we filtered the rows down. And you could do something like a logical operator like and then we can put in another statement. Again, notice that we're using bare variable names, so we don't have to do empty cars.mpg. We can forget all that mess, all that noise. And we can also do cylinder does not equal 8. Let's run that one more time with a cleaner console. Okay, cool. So now we see that filter has these 2 different conditions, and it's essentially saying this has to be true and that has to be true. Well, that's one way to do it. Another way to do it is to simply start a second argument in filter. We'll separate that by comma, and this is doing the same exact thing. MPG has to be less than 20, and cylinder has to not equal 8. Right? So this, in effect, by making them separate arguments, is doing the same thing as and, the and operator. In other words, this has to be true and that has to be true. If you wanted to do an or statement, you can use the or logical operator and you will get something like this. So let's do does not equal 8. And we can also do an and statement. Cylinder does not equal 6. Will we get anything? Let's find out. Maybe I'm using this incorrectly because it seems to be returning all of these, but hey, that's okay. That's how you learn. So anyways, do stick with that. Recall that you can have multiple conditions set in the filtering statement, and again, that's helping you reduce your rows. So if we were to combine these, we could do empty cars, and then we can say select MPG, cylinder, horsepower, and weight. Let's do that. And let's also use this same filtering expression. So we only want these 4 columns plus the row names. And then we want vehicles that are less than 20 miles per gallon, and then cylinders are greater than or equal to 8. So there it is. We've got a nice clean data set with a reduced amount of columns, also known as dimension reduction. So we've reduced the dimensions, and we've also reduced the dimensions in terms of the rows by setting these certain criterias in filter, or criteria, excuse me. Okay, so that is another, that's the second main verb that you'll encounter when it comes to using dplyr. Let's look at this third main verb, and this is called arrange. And what does arrange do? It in effect orders your data, or it rearranges it. So if we look at empty cars, and we'll add it to this so it's a bit cleaner to see, we can see that miles per gallon is not in ascending or descending order. In fact, it's not seemingly in any order. So what we can do is select miles per gallon. And if we do that, now we can see that it starts in ascending order with the lowest miles per gallon, and it goes all the way up to the highest miles per gallon with the Toyota Corolla at 33.9. And so now that is ordered, and we have a little bit of natural ordering that occurs with cylinders because, of course, lower miles per gallon is associated with higher cylinders, but it's not exactly perfect. So how do we change that? Well, it turns out that you can actually use arrange on multiple filters, on multiple variables. So if I run this, it's going to give us first the lowest cylinders. This is ordering by cylinder first. So it's going to start with all the 4s, then it's going to start with all the 6s, then it's going to start with all the 8s, or it's going to end with all the 8s. Now, in each of these, where it goes to 4, the miles per gallon goes from least to greatest, and then in the new category 6, it starts again over from least to greatest. And then finally, of course, an 8 from least to greatest, all in their respective categories when it comes to cylinder. So that's important to keep in mind, is that you can not only, we can do this by cylinder, we can do this by, one variable, we can do it by 2 variables, and in fact, we can even go further and do it by 3 variables. So if we did cylinder, and then we did V-shape engine, and I'm just going to go ahead and use select to make this a bit easier to see. And so we can do the same exact variables that we're using. Let's run it. Cool. So now this is in order of whether or not it's a V-shaped engine. But first it's ordered by cylinder in arrange. With V-shaped engine, that's the next level of ordering. So whether it's a 0 or a 1. So notice how when we start in 6s, it starts with 0s and then it moves on to 6s and 1s. 8 is almost all V-shaped engines, right? So miles per gallon then is in least to greatest in the category of 4-cylinder and 0 for a VS. And then least to greatest in the category of 4-cylinder in a VS of 1. And then we see that continue all throughout for all 3 different classes of cylinders and all different classes of whether it's a V-shaped engine or not. So that is a range. One important thing to keep in mind is that if you want something to be arranged in descending order, so let's go back for simplicity's sake. And we can look at what that looks like without with only arranging by MPG, And then so when we do it by MPG, we can see it goes from least to greatest. That's called ascending order because the number ascends or it becomes higher. But if we wanted it to become descending, there's a little dplyr helper verb that we can use, and it's desc or descending. Now when we use that in the context of function arrange, we can see that it starts with the highest value and then it works its way down to the lowest value. So one way to do this that's shorter and easier and very sort of reminiscent of select and saying no, we don't want that particular variable, we can say, instead of actually typing out descending, we can actually just do the minus sign in front of the bare variable name. And if we do that, it is also descending. So again, starts with the highest and it descends to the lowest value. So that is a range. Again, we've talked about columns, we've talked about rows, columns selection with select, row filtering with filter, and then arranging your rows or your by values with function arrange. So again, all of these are key dplyr verbs. So next, let's move on to mutate. Now, what does mutate do? Well, it is, in effect, takes existing variables and it creates new variables out of some formula that you put together. And you can name those variables whatever you want. And in fact, that's the first thing that comes in a mutate function. Again, just as a reminder, we're piping the empty cars dataset using this pipe operator straight into function mutate, and therefore we don't have to use this first argument, which would normally hold empty cars. And just like bare variable names, when we're using select, when we're using filter, or anything like that, mutate, we don't have to put our variables in any particular format. We can just simply create a new variable, and we're going to call this variable pounds. And why are we going to do that? So again, what I mean by that in terms of no particular format is it's the bare variable name. It's not in quotes. It is not preceded by a $sign and then the empty cars dataset name or anything like that. Excuse me. But if we look at empty cars, we can see that weight is 2.6, 2.8, 2.3. And all right, so that can't be pounds and that can't be kilos. So what can it be? So let's look at the documentation one more time. And if we look down here, we can see that in weight, it is weight by 1,000 pounds. So what we're going to do is, again, we start with the name of the new variable we want. We're going to take the variable weight, and we're going to use arithmetic operator multiplication by 1,000. What's this going to do? It creates the new variable LBS, or pounds, which is a United States metric for weight, and it multiplies it by what we can see in the documentation are the actual units of analysis, and so or the units of measurement. And so weight being 2.6 thousand pounds, if we multiply that by 1,000 in this formula, we actually get the real number of pounds per each vehicle. So this is an example of mutate. Again, we're creating this new variable. We're putting an equal sign between the new variable name and the formula for the new variable. And we're using existing variables like weight or like miles per gallon and using some other formula to transform those variables into this new one that we can see here. In this case, pounds. So that's new variables. And those are 4 of the 5 key verbs in dplyr. Lastly would be summarize. And I would include probably a 6th dplyr verb as well that we're going to go over. But what does summarize do? Well, in effect, you guessed it, summarizes your data. So we can take summarize and quite easily simply take, for example, mean miles per gallon, if we can spell it right, and then we'll actually just use mean miles per gallon. So again, we're going to use the function mean, and we're going to use the bare variable name mpg, and this is all happening in the summarize function. What's important here is that this is the summary on the right-hand side, and this is going to return a single value. It's the average miles per gallon for all 32 vehicles. However, it also is something that we can name, and that's because with summarize, we can create multiple summary statements or multiple kind of summary metrics or statistics, depending on what we want and how we want to summarize our data. So let's just run this and see what happens. So there we go. We get the mean miles per gallon. That comes out as the first row. And we also get the name of that summary statistic that we decided to create. For those of you, by the way, who are not accustomed to US spelling, you can also use summarize with an S. And that's true with a lot of these different tidyverse packages. There is a sort of UK version of spelling that, if you will. So we did one summary statistic here. Now, summarize only works, unless you're doing some sort of a grouping function, it really will only work if one value is produced. So if we wanted to try and get return all of the uniques or something like that, let's say, for example, unique sill. So let's say we want it to return unique sills, then we actually call unique cylinder, which normally would give us 4, 6, and 8, what happens? Well, it says still not found. Oh, I didn't wrap up that expression there. Oh, hey, look at that. Okay, cool. So this is interesting. This is not something I was expecting. Man, I work with dplyr literally every day. So typically, though, if you have more than one, if R is expecting only one value to be respond with using summarize, it's going to throw an error. So that's something to keep in mind. Unique was the first thing that actually came to mind. But what if we wanted to do something like table? So if we did n unique sil, and here we do table. Let's try and break it. Son of a gun. Well, I think that they've made some improvements on dplyr. Okay. Well, anyways, so again, the point here, wow, that's really cool. I had no idea that would work. So the point here, though, is summarize allows us to be able to create these different summary statistics. That's interesting that it does this automatic grouping. I was not expecting that, and that's not normal behavior that I'm accustomed to with dplyr. But again, they're always maintaining these packages and improving them. Kind of funny. At any rate, we can also do things like median MPG. We'll just call that med MPG. We'll do median MPG. And so this is an example of a singular value that you'll get. And so that becomes repeated because it's across all cylinders, et cetera, which is nice. One helper that you can use, it's called the helper function. And we already saw this with descending when we were using arrange, is function n. And so n actually counts the numbers of observations in your data set. So here it's just saying 32, 32, 32. So very cool. So summarize, in effect, allows us to create this much smaller either single row, or as we can see here, multiple rows that comprise this data frame of all of these different values. And these values are summary statistics or some sort of summary key indicators for your data set. And that's huge when it comes to just basic summary analyses and allowing your data manipulation pipeline upstream to take care of all this pre-processing, like filtering your rows by certain conditions, filtering what columns you want to show, putting it in a particular order, and then you pipe that all into a summarize. It really allows for a smooth process from your original raw data all the way down to this sort of small summary table. And you can do this just in a few lines of code. As we've seen here, we could combine all of this. So there is a sixth, and we'll just put summaries here. Now, normally I would try and put these comments on the same line, but I want to make this video a little bit faster for everybody. So there is another powerful verb in dplyr, and it is called group by. And so group by essentially does what we saw here. Where we saw this unique number of cylinders. So if we group by cylinders, 6, 4, and 8, out of order, yes, unhelpful, no, we can see that this is able to take the n, or the number of vehicles in each of those groups. Now, I think these might be switched around because I think there's less. I think there should be 7 6-cylinders, but regardless, let's see what that means. We can group by a variable. And now with empty cars, you've only got a few variables that are sort of binary or categorical. So we can group by 4 gear, 3 gear, 5 gear engines. We could group by the number of carburetors. We can group by engines shape or automatic or manual transmission. And we can also group by cylinders. If we group by cylinders here, that's a nice, easy way to understand it. I'm going to press Control-Shift-M. To create my pipe. And so we want to group by cylinder, and we could do something like mutate. So if we group by cylinder, we can take sil, av, average MPG. And that's just going to be the mean miles per gallon for each group of cylinders in this data set. So here we can see this repeated value a lot. I'm going to go ahead and save this as a temporary variable so we can take a better look at that. Okay, so now we're looking at average, the cylinder average mile per gallon. And so we can see that for 6-cylinder engines, that is the same value for every single time 6 cylinders appears. When 4-cylinder engines appears, we can see that unique value repeating itself, 26 miles per gallon. And when 8-cylinder engines appear, we can see all these 8-cylinder engines, we can see that those all have the same MPG. So we can even use select to make that a bit more visible. And then we'll do MPG and so. And we did so. Cool. We'll arrange by that. And so, of course, we have our 4-cylinder engines all on the top, and then, of course, they have all the same MPG. That's because we've grouped by cylinder, and then we found the MPG for that entire group, which is really cool. And so then you could do something like, if we wanted to create another mutate, we can take each individual vehicle that exists, and we can do AVG diff. And this, we're going to simply take miles per gallon, and that's the miles per gallon of the vehicle. And let's do, so I'm doing this correctly. Let's actually take the mean miles per gallon for the cylinder group, and we're going to subtract the individual vehicle's miles per gallon from it. And that's going to give us a series of positive and negative numbers. And that's fine. So that's the difference between the average miles per gallon versus the individual vehicle's miles per gallon. And if we wanted to, we could even do a verb like absolute, which gives us the absolute value. In other words, negatives become positive and positives stay positive, just like you should while you're learning R. So we've also got ungroup. Let's do that too. I'll talk about that in a second. But the idea here is that we're able to group by cylinders. Let's even do arrange. We're able to group by each cylinder, and then we're able to take the average miles per gallon for each cylinder group, and we're able to find the individual differences for each vehicle compared to that group summary statistic. So that's quite neat, and that's just an example of a group by mutate operation. So that's group by working with mutate. Now, remember that whenever you group data, try and include, this is not a key verb in dplyr, but try and include ungroup afterwards. You can have unforeseen consequences downstream in your data processing pipeline if you have grouping variables still working under the hood. So you want to make sure that you use ungroup every single time that you use a group by, unless you're going to use a group by and then another group by and another group by, and this sort of recursive grouping processes. So again, use ungroup after a grouping expression as well. Now, something that's much more common to me when it comes to summary statistics, rather than group by mutate operations, is a group by and summarize operation. So we'll do group by cylinders, and we'll simply pump that into summarize, and just for the sake of enforcing the importance of the ungroup function, I'm going to put that at the end there. So summarize, cool. Let's take mean weight, and we'll do function mean with variable weight inside. Cool. We can do more. Let's take the median let's take the mode of cylinders. Awesome. And let's also get the median mpg, or miles per gallon. So here I'm just using core R functions, if I can use them right or spell them right. And let's go ahead and see what pops out from this. Cool. So we get our each group because we've grouped on cylinder, and then we're able to get the mean weight for cars in each of those groups. Now this makes sense. 8-cylinder cars would be heavier. So this isn't the in the statistical mode. This is giving us the, in essence, the class of the values themselves. So, excuse me, apologies for that. And median, of course, is giving us the median value of miles per gallon for each cylinder group. So, cool. That is, again, a rather than group by mutate operation, that would be a group by and summarize operation. So do keep that in mind. That makes group by probably one of the most powerful verbs, and I would consider it, the 5 key verbs plus 1, right? So group by really is incredibly powerful, especially when, no pun intended, grouped with these other key verbs. And so that actually covers pretty much everything in terms of the main verbs that you're going to use in dplyr. There are a few other things like helper functions or helper verbs. And we already looked at a few already. So we had n, which simply returns the number of variables. So does count. Also, not variables, excuse me. N returns the number of rows. Count returns the number of rows. We had descending, which can take, when you arrange data, this reverses that, because when you arrange it, it's usually in ascending order from least to greatest, and descending order will reverse that from greatest to least. And you also have really a host of other helpful verbs, and I'll give you one such example. If we were to take empty cars, and we were simply going to select the variable miles per gallon, that's what that looks like. All fun, all good. But what if we're only selecting one variable? It's miles per gallon. But what if we wanted to pull this out not as a data frame, in other words, in this tabular data set? Because look what happens when we save this, and I'll save this in overwrite X. It's data. It is, by definition, a data frame. And so maybe we don't want that. Maybe we want miles per gallon as a vector. Now we can easily do that by simply doing x mpg, and there we've extracted it as a vector. It's not tabular, it doesn't have rows and columns, it just has every single value for mpg for all 32 vehicles in our data set. But you can use a function like pull, and let's not even do assignment with that. And so if we use helper function pull from dplyr, then we've pulled that out as a vector, and it's no longer tabular data. And I can't stress enough to you the importance of pull when it comes to wanting to do a bunch of filtering operations, doing a bunch of any of these kind of main helper verbs, doing mutates, etc., and then you want to just pull out a single variable from that chain and then use it as a vector. This is the way to do it, and this is also a relatively new addition to dplyr. This didn't exist when I first started using it, so that started maybe within the last couple of years. And so, yeah, so tons of different helper verbs, and lastly, let's put it all together and create sort of an example of all of these verbs working in conjunction. So again, we had select, we had filter, we had arrange, we had mutate, and we had summarize. And so let's go ahead and take empty cars. and we're going to put this in a single expression. Remember, we start with the data set and we pipe the data set into a new function. We'll select simply cylinder, mpg, weight, and engine size or displacement in cubic inches. We're going to filter out any vehicle that doesn't have exactly 4 cylinders. So we're going to preserve only cylinders. Let's look at our data so far. Okay, cool. Let's arrange our data in descending order. So we'll start with the greatest by miles per gallon. And so they're all 4-cylinder engines. We know that. We start with the greatest miles per gallon, which is the Toyota Corolla, and the smallest engine, the smallest engine. And then we can do something like mutate, and we'll create the average or the weight for each vehicle in actual pounds. So we'll call that LBS. We'll do weight times 1,000. Cool. And so now that we've got 1,000 pounds, let's go ahead and we'll use a group by cylinder. So we're going to look at only, let's not do, let's add something new in here. Let's do, I wonder if there's going to be any V-shaped engines. Let's find out. Yeah. Okay, cool. All right. So we're going to group by V-shaped or not V-shaped engines. And we're going to summarize with the average number of pounds. And so we'll use mean LBS. Now remember, we just created this variable up here in this mutate operation. And we'll use ungroup. And there we go. That is an example of using all of these key verbs, plus we could have used a helper verb here, but that is doing the same thing. Let's just put one in there to say we did. So great, we've got all 5 key verbs. We've got the 6th group by verb, and we've got a little helper verb in there to help us out. What is this doing? Again, we're starting with the data empty cars. We're choosing these 5 different variables and excluding all others. We're choosing only rows which have 4-cylinder engines and excluding 6 and 8-cylinder engines. We are arranging them in descending order by miles per gallon, starting with the greatest miles per gallon at the top. We are creating a new variable based on an existing variable weight to show the actual number of pounds, and we're calling that LBS for pounds. We're grouping by the engine shape. When we group by the engine shape, we want to know the average number of pounds, and so we're creating the name of that variable is AVG pounds, and that equals the formula, which is taking the means of this transformed variable pounds, and we're taking the mean for whether it's V-shaped or not V-shaped. And then we're ungrouping because you always want to do that after a group by operation. And there we have it. So the average number of pounds for a non-VS, let's see. So VS, 0 equals V-shaped and 1 equals straight. So for V-shaped engines, the average number of pounds is 2,140. And for a non-V-shaped or a straight-shaped engine, it's 2,300 pounds. And we were able to do that in a single fell swoop using all sorts of key grammar manipulation verbs from package dplyr in this kind of fell swoop. So that's really showing kind of a tour de force of the package and how you can create relatively clean code, relatively well organized, and certainly understandable to future you once you have learned this a little bit more. Package dplyr allows you to do that, and it also works with, say, pipelining these data directly into a ggplot2 function, or tidying these data using the tidyr package, different functions like that. So not only can we manipulate these data, but we can push them straight into another series of functions from tidyverse packages, or even in many cases core R functions as well. So this again was a tour de force of dplyr. I hope you enjoy exploring it. Try out with new data sets, and there's even a new Star Wars data set that comes with dplyr once you load it. So get excited about that. I know I was when I found that out. I really didn't know until a couple days ago. All right, enjoy, have fun, take care of yourself. Thanks for watching.